Некоторое время мы выжидаем. Я не вижу Шалаева пока. Есть, да? Да, чтобы можно было всех видеть. Ага. Не вижу пока. Коллеги, всем видно? И поднимите руки, если меня видите, слышите. Все отлично. Давайте начинать нашу конференцию. Конец года. Все люди достаточно заняты, поэтому будем вносить некоторые изменения. Куча совещаний сегодня всяких. И даже до моих вступительных слов слово попросил Антон Павлович Шалаев, поскольку ему надо срочно уезжать, он выступит, а потом я общие слова скажу, и начнем приветствие, и наша конференция заработает в полном масштабе. Антон Павлович, готовы? Подключайся.
So we are going to greet the first speaker,
Добрый
Anton
день,
Shalaev. So, good
уважаемый Сергей
morning,
Анатольевич,
dear
уважаемые
Sergey
коллеги.
Anatolyevich, dear colleagues.
Очень рад всех видеть.
I'm very glad
Действительно,
to see you
традиционно,
all. So
ежегодно
that's the
мы
annual
собираемся
traditional
на
conference,
конференции IT-стандарт. Правда,
IT
обычно
standard.
происходит это в замечательных залах ИРА
But usually
весной.
it is held in
В
IRA
этот же раз у нас
Technical
несколько
University,
изменились
but
традиции с точки
nowadays
зрения формата
we
и
have
места,
changed the
формата,
format
места и
when it
времени
comes to
проведения.
the
Но,
time
надеюсь, это никоим
But I
образом не
hope that
скажется на результатах
it wouldn't
сегодняшней
influence the
конференции.
results of
Я искренне
conference.
хотел бы еще раз поблагодарить
So
Сергея
I sincerely
Головина,
thank
Андрея Николаевича Лоцмана, Бориса
all the
Михайловича Поздеева
organizers of the
за
conference
традиционную поддержку и за
for the
традиционный
traditional
интерес,
support and traditional interest
который вы не только, скажем так, демонстрируете, но и максимально
you show
развиваете ко всему, что
and
касается
develop.
вопросов цифровой трансформации и
So when we talk about
стандартизации.
the
Буквально
standards
несколько вводных
and
слов хотел бы сказать. Я
technologies.
планировал сделать сегодня большой доклад, но
So
буквально
I wanted to present a report, but yesterday evening
планы, но не
my
посетить
plans
конференцию не
changed.
мог, поэтому разрешите
But of course I
короткое
couldn't
вступительное
skip this
слово.
conference, but I wanted
Вы все
to
знаете, что
deliver
в прошлом году в российской
So last
стандартизации
year, the Russian
прошло очень важное
standardization
событие. У нас впервые появился документ стратегического уровня, определяющего приоритетные направления развития стандартизации в Российской Федерации на период до 2027 года. Дорожная карта развития стандартизации, утвержденная правительством Российской Федерации. Дорожная карта содержит более 50 мероприятий, которые вот уже почти год мы, не только ведомства, ответственные за стандартизацию, но и в первую очередь те, кто активно участвует в разработке стандартов, в применении стандартов. А вот уже год мы стараемся выполнять те мероприятия, которые представлены в дорожной карте. Все мероприятия разбиты по нескольким крупным приоритетным направлениям. Это и совершенствование нормативного регулирования, это и применение стандартизации как элемент регулирования в закупках, это и международное межрегиональное сотрудничество стандартизации. Но очень важное направление – это развитие инфраструктуры стандартизации, в том числе цифровая среда стандартизации. Данное направление мы предполагаем закрепить на законодательном уровне. К сожалению, я не успеваю сегодня похвастать перед вами тем, что изменения в российский закон о стандартизации связаны именно с цифровой трансформацией приняты, но мы ожидаем, что это произойдет в ближайшие буквально недели до Нового года. Еще один важный момент, которым хотелось бы похвастаться. В этом году количество российских национальных стандартов и применяемых на территории Российской Федерации межгосударственных стандартов в области информационных технологий, цифровых технологий превысило 1000 документов. Это колоссальный объем. Это все еще меньше, чем соответствующее количество документов в МЭК, в ИСО, но для нас это значительная цифра. Эти документы охватывают очень большое количество направлений. Это и традиционные сферы применения IT, это сферы больших данных, это новые для нас сферы, такие как искусственный интеллект. В этом году появился целый ряд стандартов искусственного интеллекта. Это стандарты в области компьютерного моделирования, некоторые из них уникальны, в том числе для международной практики. Однако мы столкнулись с серьезной проблемой. Появление такого большого количества стандартов зачастую связано с риском несогласованности стандартов между собой. Появляется все больше технических комитетов по стандартизации в новых областях. Росстандартов, национальный орган по стандартизации, всячески поддерживает деятельность этих технических комитетов. Однако мы сталкиваемся с тем, что координирующая роль деятельности по стандартизации в IT-сфере абсолютно необходима. И в этом плане мы хотели бы поблагодарить, я вижу, здесь присутствуют наших уважаемых коллег из Германии, участвующих в российско-германском диалоге между Российским союзом промышленников и предпринимателей и коллегами из Союза восточной экономики, Германского союза восточной экономики. Дело в том, что мы видим, как германские коллеги смогли благодаря платформе индустрии 4.0 консолидировать работы по стандартизации всего, что связано с развитием цифровых технологий. Мы считаем этот опыт чрезвычайно успешным, чрезвычайно интересным, и поэтому, я думаю, коллеги сегодня расскажут, и Сергей Анатольевич расскажет, и Борис Михайлович. Буквально несколько недель назад мы поддержали появление Координационного совета по стандартизации в сфере цифровых технологий, выполняющего, по сути дела, функции обеспечения межведомственного взаимодействия всех участников процесса разработки цифровых стандартов, направленных на регулирование цифровых технологий. Мы надеемся, что подобная координация позволит повысить, поднять еще на более высокий уровень работы по стандартизации в этой сфере.
Hope that today, during this conference, we will hear the suggestions and new fields will be determined so that we will consider these ideas and this coordination, the council will consider all these ideas. And I hope that we will have fruitful work today. I'm sorry that I can't participate throughout the whole conference, but I wish you good luck on behalf of all the committees and organizations. So all the standards and all the roadmaps that we planned for the following years is all this whole trend is an important thing, and I hope that we will be able to realize all these tasks. Thank you very much. Thanks a lot. So we have that in a reverse order. But now we turn to the usual aspects of our conference. First, I'd like to say that we have we work in two-language work, two-language Word. So we have different links. I hope that it's working fine. And so we'll have the simultaneous translation. We'll not lose any time. The second thing, I'd like to express my gratitude to all the members and friends from Germany and from Russia. And I hope that our conference, despite all the troubles due to the coronavirus, and I hope that we will have fruitful results. Usually, that's the 10th anniversary kind of conference. We usually had some sections, roundtables, and masterclasses. So, according to the plan, we were supposed to have the roundtables in spring. So we had like our works and papers of the conference already published. So moreover, at our website of the committee, we have all these materials published on the website available for everybody. So, and today we have our general meeting that was supposed to be like half a year ago. We decided to focus that on a major question, that is the Industry 4.0. And we are looking forward for the ideas of our German colleagues, and we'd like to share our ideas and directions that we are working on. So we're working with in a non-stop basis and non-stop mode, and because we have remote access, so now we move to the conference itself, and I'd like to give the floor to our rector of the RTU Mira, Russian Technological University, that holds the conference, really. Stanislav Sergeyevich Kudr. Okay. Dear colleagues and friends, let me welcome everybody on the conference, IT Standards, even online. So the major conference is the exchange of expertise and experience the Russian and German colleagues. So it's really important to work on the mutual strategy in terms of development in AR and VR technologies, big data, and other research-intensive technologies being developed. So we consider the following troubles that increased research-intensive fields lead to job losses, and we understand that there is vast need to prepare the future, the following robotization and automation. So Mira is Russian Technological University is working hard on creating this basis for the transition towards automated grid. So we have more than 8,000 students accepted to the university every year. So we prepare students and experts in automation, biotechnology. We usually always upgrade our technologies and our technological basis. We have tight connections with different committees and organizations throughout the world, and apply the newest, the best technologies to our studies. So I hope that we'll be able to harness all the best ideas that the Industry 4.0 has, and I hope you have good luck. I wish you great health in the future. So I'd like to add that we have held 9 conferences out of 10 on the basis of this university, and I hope that we'll continue having this conference on the premises of Iran. I'd like to give the word to Jans Berman. Jans Berman. Okay, I hope that you can hear me all. Good morning, dear friends and colleagues. We are really glad that we participate in this conference, and we can. And this is the second time we meet during this week. So the technological regulation and standardization is really important. So it's really important both for us and for you. So that's the basis of the cooperation in the future. I suppose that most of you know that the Industry 4.0 is was first initially created by the German people. So and the fact that we are talking about the IT standards began as a revolution in Germany, the revolution that was that was a very super important subject, and we understand that the best and the smartest experts from Germany they participate in the conference, and believe me, they know what they're talking about. That's a good basis for covering all the questions and issues that might appear in IT standardization and information technologies in general. And as you know, we do everything to move forward. Why? I know that as everybody knows, it's not just the coronavirus that affects us, both economically and politically. So I believe that the way we're doing it now, working out the way out of these troubles together, is the way it should be. So as you know, this year we have the first German and Russian committee, council, industrial council, and as I see it, that's a sign of cooperation and our ability to cooperate, to work together. So what I can hope for are the wonderful conversations. I hope that we will find opportunity to cover various subjects, various topics. and I wish you like wonderful, good health in this deep times. So we wish you wonderful health too. So I'd like to give the word to first one of the experts, to Lotsman Andrei Nikolaevich. Dear colleagues, I'm glad to welcome you all at this traditional 10th conference of IT standard. So really, despite the pandemic, our council and the German council, we work together. In Germany and in Russia, we have a lot of things to do. So today we have the first meeting of the Russian-German committee, Russian-German council, where we have representatives from a variety of ministries. We have our own representative, and we have our own subjects that we would like to cover in these discussions, so that it will be that this topic will be discussed by Minister Reshetnikov and other politicians and experts, and we also give information about the reports that our the results that we have this year. So I'd like to express gratitude to our colleagues in Germany for participation in our conference, and people from Rostandard and Minprom.org and other organizations in Russia. So I hope that next time we will see each other face to face. Like next time we like greet each other like formally in the conference next time too. So, and thank you very much. And I'd like to give like welcoming word to the Vice President of the Russian Union of Industry Workers and Entrepreneurs in Russia, RSPP. Morning, dear colleagues and friends. I'd like to welcome the participants of the conference. The IT standard, that's a 10th conference, and that's a traditional one for us now. So I'd like to say that information technologies have a prominent role in industry, trade, education, where we have like all this basis for international cooperation, and this trend of international cooperation should stay, and we should work together on creating the standards and the documents that cover the communication between the parties. So while we are moving towards the digital economy, we need to pay attention to automation in industry, and we need to work upon the industry 4.0, 4.0 in terms of industry, and so that we could work together in national fields and international fields, so that we could work together with other countries. So the strategic tasks that we are having in front of us, I hope that will be covered too. So in November, we had the meetings of new novel conferences, novel committees, and I hope that in the future, all these efforts will lead to the international and national standards being developed. So I hope that our German colleagues and our Russian colleagues will work together, and this dialogue between Germany and Russia in terms of industry development and standardization will lead to like fruitful results in terms of the solving the issues, solving the problems of international cooperation. And in the end, I'd like to wish all the participants well, fruitful results. Thank you very much. Thank you very much for your participation. So these was the welcome word from the Russian Union of Industry and Business. Now I'd like to give the word to the measuring department representative, Burmistrov Vyacheslav. Morning, everybody. Thank you very much for giving me the floor. I'm really glad to see you all. Thank you for this wonderful opportunity to participate in this event. This is the second time I have been to this conference, so now so for me and for my colleagues, this is a wonderful opportunity to exchange our ideas and see, listen to representatives of our national and foreign companies and industries that are leading the field of digitalization and standardization from Germany and Russia. So me and my colleagues, we are working on a bit of a different level, but thank you very much for inviting me. So the topic of my today's report is to cover the topics of technical regulation and standardization. So I think that it will be interesting for my colleagues to listen to those major directions that we see as the most important ones, and we also need to understand what the industry thinks is important, what other countries think is important in digitalization. So digitalization in technological regulation is really important. It's one of the major strategies up to the year 2025. So the Russian Federation has this as a major strategic point of development, and we think that controlling these standards will lead to major technological advantage and protecting our markets. And so the delivery chains and supply chains and creating all these so creating the delivery chains, supply chains, leads to the need of standardization of all the production on all this every step. So I'd like also to say that federal law, in terms of the uniform measurements in Russia, so and we prioritize electronic and digital means of measurements, and also we have some other legislative initiatives in state Duma in terms of standardization, and that will allow we'd like to establish the BERESTA standardization, measurement, and control system. That is the system of standards that we are planning to introduce in the following years. So this is the federal legislative initiatives that we support. So you see that developing the documents that regulate the industry, and we also regulate the measurements of the products and the codification of products, and so that the requirements to the products would meet the requirements of every supply chain parts of the production. So I also would like to highlight that we have the uniformed registry of the documents, so that the system of transparency would be established. So we are working on synchronizing all the ideas and all the data that we have from different ministries and different organizations, so that we'll create this transparent system of uniformed register of all the documents, so that the industrial products will be standardized, including all the documents that like about the products meeting the requirements of various industries and participants of the production. And that's why we probably need to move to the completely electronic, completely digital means of exchange of documents and various acts. So the GT numbers and GLN numbers should also be like highlighted in these documents to use them too. So, and as the third, like future step, long-term step, we are moving from the natural experiments, natural tests of products, to move to the digital experiments, digital testing of products. And I would like to hear more ideas about this new vast subject and the way it might be realized. So, so all these steps that we are taking, as we hope, will lead to a huge leap in terms of technological advancement in Russia. And with Rostandart, we're synchronizing the Russian information system, Cyberberestar and Arshin, all these systems of measurement, digital measurement and digital standardization. And the upcoming digital and information technology services that we have in Russia will apply to the standards that we're developing. And it's really important from the one point to synchronize between the industries and ministries, and on the other hand, and the headliner and for us to be the headliner of of creating the models and advancing these experiences to the international fields, so that share with our experience with other people, with other countries. So the national and the international level we will have to apply to the requirements of the national and international subjects of production. So so all these changes, are planned in our following upcoming programs of our department and other departments in place. So thank you very much for participating in our conference, and we hope that you will participate in the future conferences too. So, and now
So everybody, I hope you can see my screen. Yeah, I see some. Yeah, that's great. Thank you. So here, I'm starting with a quite practical topic about a smart electrical connector, which is enabling tomorrow's production. So I'm with TE Connectivity, one of the largest manufacturers for connectors. But this is actually a joint effort of multiple connector manufacturers, and especially a research facility in Germany, which is running one of the most prominent Industry 4.0 test beds, the Smart Factory Kaiserslautern. And the Smart Factory Kaiserslautern has a vision which is called Production Level 4, which is kind of derived from the levels that we know from autonomous driving, where level 4 identifies a level where routine activities are performed by fully automated and AI-supported machines, but the central decisions are essentially made by humans, meaning the human being keeps the control over the entire process, but he is strongly supported by automated systems and artificial intelligence. So the main thing here is, or the key aspect is, that operators have a direct access to process information, and they can intervene whenever possible, whenever required. But as I said, the production level itself is run autonomously. The Smart Factory Kaiserslautern provides a modular, flexible production system. So this production system consists of several individual modules which provide autonomous production services, meaning one module, for instance, could provide some stamping service, another some stitching service, and some testing service, things like that. And then those modules are simply combined to an entire production facility. And the infrastructure connecting the autonomous modules and its governing infrastructure execution system are central enablers here. So you might imagine that there is some coordination effort required for those individual modules, and it is essential to combine them in a certain manner to really ensure that they are interacting properly. And that's why this infrastructure execution system has a key role here. And this infrastructure execution system and the entire infrastructure provides a unique connector, which is used to connect those individual production modules to the infrastructure. So there's one single connector that should be used to actually establish this connection. And the reason for that is that you would like to recombine the production modules so that you would change the production servers from one product to a different product by simply reconfiguring the production facility. And that's why you actually need a simple or a single interface that would be applicable for all of these production modules. So actually, one of the objectives of the Smart Factory Kaiserslautern is to enable even the untrained user to establish the connection. So there's a project called Smart Connectivity under this Smart Factory Kaiserslautern, where connector manufacturers have jointly defined the requirements for such a smart connector. And the idea is that even the untrained user can reconfigure the production facility safely without harm, without hazards, or without or being protected from hazards. And that means that there needs to be some intelligence in the production system, and especially in the connector itself, to avoid the user from touching active currents or active parts that are powered with currents. These requirements that we gathered at this Smart Factory Kaiserslautern were then fed into a standardization activity in the DKE, where a working group on electrical connectors with additional functions, Industry 4.0, was founded. And this working group actually defines a standard based on the Smart Factory Kaiserslautern's requirements. So about those requirements, so some of them are quite simple or straightforward, as you might expect from a connector. So this connector actually provides connections to a power system, 400 volt AC, and to a communication system. Data connection is provided via Ethernet and powered in one single hybrid connector. And beyond that, this connector should provide an automatic deblocking. For instance, when a suitable mating partner is detected, essentially the socket should incorporate some kind of blocking mechanism, which is then removed in case a suitable plug is approached towards the socket. And then the socket is also incorporating an automatic locking mechanism when the end position is reached after mating, meaning the plug is inserted into the socket, and once the end position is detected, an automatic locking mechanism should be activated. That ensures a safe locking and unlocking depending on operation, meaning as long as the production module is powered, the operator shouldn't be able to unmate or unlock the connection. So in terms of technology, what's happening inside the connector or the socket is that the socket incorporates actuators and sensors and also a local processing unit, including an RFID reader for this partner detection. And the plug is a simple passive electromechanical component equipped with an RFID tag. So the socket essentially carries out the task of blocking and unblocking through the incorporated electronics and sensors, whereas the plug is a simple passive component, which just delivers the information on its own identity via this RFID tag. We also decided that identical sockets should be incorporated in the infrastructure node and the production modules, so that a production module is connected to the infrastructure node via a symmetrical cable, which we called patch cable, which is maybe a term that especially applies to communication cables. In this case, it's of course suitable also for this power and data connection cable. So what you can see here at the bottom of this slide is the architecture that is provided in the Smart Factory Kaiserslautern, where you have an infrastructure node equipped with such a socket, a production module equipped with the same socket, and in between a symmetrical patch cable, which provides two plugs to establish this connection. And both sockets provide the functionality that I described earlier with this automatic blocking and automatic locking feature, which is enabled through some incorporated sensors, actuators, and local processing units. So there are connector concepts available, actually multiple of them, and the best of both, or the best of all concepts that have been proposed to the Smart Factory Kaiserslautern and ultimately to the DKE, the best of all of those concepts now need to be combined into one resulting concept, and that's basically where standardization plays the key role, as you might expect. So yeah, we are talking about Industry 4.0, and there shouldn't be a Industry 4.0 presentation without reference to this reference architecture, Industry 4.0, and that's of course the case also here. We have the socket and the plug, which are the assets at the lowest levels, and then we have the asset administration shell, which encapsulates the data model, which encapsulates the data for both the socket and the plug, and which also provides a service interface which enables the standardized Industry 4.0 communication either with each other, meaning between the socket and the plug, or with the higher level IT systems, such as the infrastructure execution system that I referred to earlier. So there's one very essential distinction between the socket and the plug here, which is reflected in the integration layer of the RAMI 4.0. And this is about the way how the socket or the plug are integrated within their administration shells. So for the active socket, it's quite natural that this is done via some kind of active communication, which is in this case proprietary between the socket and the host of the asset administration shell. So it's very essential to distinguish here between this proprietary active communication between the socket and its shell, which is in the integration layer, and the standardized Industry 4.0 communication, which is on the communication layer, and which is essentially standardized in this DKE project, whereas this proprietary communication is not part of the standardization, and this is something where manufacturers may distinguish. The plug, on the other hand, is integrated via a unique identification, meaning there's no active communication between the plug and its asset administration shell, because the plug is simply a passive electromechanical component. But through this unique identification, it is possible to associate the plug with its asset administration shell, and essentially the update of the asset administration shell needs to be accomplished by the user or by the system that this plug is embedded. Yeah, so how can we derive a data model and a service interface for this active component, meaning this complex component, I should say, meaning the asset administration shells for the plugs, for the plug and the connector, for the connector components, which are the plugs and the socket. So what we did, or how we started, was to collect the use cases for a connector. Sounds quite simple because a connector provides a connection and should also be disconnected, right? And then there's also this operation piece in between, and that's essentially what we also identified as the use cases. But then, of course, those use cases needed to be detailed, and they are detailed via the so-called or the diagrams provided by the Unified Modeling Languages, UML. There are some behavioral diagrams like the sequence diagram and the state diagram. And then there are also some structure diagrams like the class diagrams, which serve the purpose of really digging into the details of such a connector and to understand which data needs to be stored within the asset administration shell, and which service interfaces needs to be provided towards the outer world and needs to be standardized in order to be able to incorporate such a connector in a higher level system. You might imagine that this connector is not only suitable for the smart factory Kaiserslautern, but this should also be applicable to any production line. So it's really essential that the production facilities can rely on a unique interface that is served through this standardization effort. So this is just one example how we tackled that. This is a sequence diagram of the use case connect. And yeah, I think I have some time to go through that, but or maybe not in detail, but just to have a high level view on that. So that there are 5 actors defined for this use case connect: the user, the socket asset, the socket administration shell, the plug asset administration shell, and the infrastructure execution system. And the starting point might be either the connection by the user or the request from the infrastructure execution system to actually establish this connection. In any case, the socket asset detects the plug and sends this information to its own socket administration shell, which then performs a compatibility check and unblocks the socket in case the two components are compatible. Once the socket is unblocked, the user is able to mate, meaning insert the plug into the socket. The mated or the insertion is then detected by a so-called mating detection, meaning this is some kind of incorporated sensor or just an electromechanical switch that is incorporated in the socket. And once the mating is detected, an internal mating cycle counter in the asset administration shell of the socket and the plug can be incremented just also for some predictive maintenance purposes. And ultimately, the socket and the plug can be locked with each other and the connection is then established. And only then the infrastructure execution system may signal to the higher level system that power may be switched on. So this is really part of a safe operation of this production module, because without or before the entire process, which is depicted here, isn't completed, there would be no power available to the module. So the worker is essentially preserved or protected from the danger of electric shock. And of course, the use case disconnect would then be quite similar, but just the other way around. So power off would be the starting point for all that for this use case before the locking the locking would be removed. Short summary and outlook. So we started with a concept proposal. This is now available and integrated within one production module in the Smart Factory Kaiserslautern. The validation of the implementation of the asset administration shell is still ongoing. So this is about the sequence diagram, which I've just referred to, and which is tested with different environments and different setups, meaning different configurations within this production facility. We are currently preparing an international standard, meaning a proposal for an international standard at DKE level. And once an appropriate maturity level is achieved, we will feed that into the international standardization, meaning there will be a new work item proposal at IEC level to actually create an international standard based on those requirements. Yeah, thank you for the attention. Was a pleasure to be with you today, and not sure whether we are able to receive questions today. Of course, I'm ready to answer those.
Now, Lotsman Andrei Nikolaevich would have to. Good morning. As you can see, the questions that we are in conference are really topical, really hot, really important for Russian industry and production. So so I represent the Committee of Russian Union of Industry and Entrepreneurs. and the Committee and Council of Standardization and at Ministry of Industry and Trade of Russia. So you see the project of our mutual work with the German government and German administration. So Dmitry Kumpiansky is the head of this council, and we're trying to solve the issues as the zeitgeist dictates us, because the standards that we have today was created 100 of years ago for the second kind of industry, for the industry 2. And today we're discussing not only the issues of digital economics and digital industry, so the machine learning and machine standards, and all these subjects are under the focus of our council. So if hundreds of years ago we had a difference in railway width, so today we shouldn't have this kind of difference between European and Russian standards today, so that the digital economy of Germany and the digital production industry in Russia would understand each other and will be able to work without any difficulties. So as I already said, our council has been working for more than 2 years, and we have worked a lot with the major companies that you can see in front of you. And I'd like to thank the administration and governments of both Germany and Russia that support our work. So we have 2 major directions of work. The quality infrastructure. This is a traditional issue of bringing together standards of our German and Russian industries. So on November 24, we had a wonderful seminar with our German colleagues. I hope that we'll continue this topic. And the second issue is the digital industry, digital economy. Excuse me. This year we had a variety of meetings and events. An important one was in February, when we had the meeting between the Russian Union of Production and Business, and Kumpiansky took part in this meeting. And the delegation from the Eastern Committee of Germany, Mr. Berman and Mr. Krause, took part in this conference too. And we created a roadmap of work for our committee, and we are following this plan. And we had a mutual conference in July, and we had more than 1,200 experts from Russia. And we had a meeting in the within the framework of the Standard 2020 conference. And briefly, the results of our work this year, we have worked out the vocabulary, the dictionary of technology, Russian, as well as in German and English. Thank you very much to Mr. Poznev for this work. I hope that we will publish this glossary soon. And next time we see each other, we will have this glossaries published. The company codex has huge work, the E-class work, in terms of E-class. And we're working upon working with the smart grid and that kind of technology too. We are discussing questions of digital application, and DAX is also participating in a meeting. So the Russian we hope that the Russian ministries of standardization will also take part in this conference, and we're also working in terms of bringing together the technological techniques of standardization of our countries. So we have analyzed the 4th edition of the Industry 4.0. Thank you. I'd like to thank the German participants for allowing us to work upon this document. So in November, the members of our committee created 71 projects of to analyze. So we're working on functional security, artificial intelligence, informational support of life cycle support, and information technologies and education. So when we started this work, we had a lot of applications from various experts and fields and various ministers, so that lots of people would like to participate in this discussion in Russia. And today we
give some suggestions and proposals
that we needed a state-level program to for the Industry 4.0, and all those changes, structural changes that allow us to support the Russian industry, so that we would reformat various funds and forms of support. I hope that this Russian, the program of creating the Russian platform for Industry 4.0 will find the support from our ministries and our government too. Thank you very much for your attention. Thank you very much, Andrei Nikolaevich. And now, I'd like to give a word to Markus Weigel, the Director of Standardization and by the Siemens Company. Thank you. Thank you, Markus. Here. Morning. Good morning.
Good morning all together. Thank you for giving me the word, Mr. President. I'd like to also express my gratefulness for the most professional conduction of our project in the joint committee in between RSPP and the German side. And in particular, the German side has always enjoyed the most professional conduction of the project on Russian side, in particular when cooperating with the academia and the universities. I hope that today's conference will deliver appropriate knowledge and information to either side to learn from each other and to give further impulses and orientation to the evolution of the digital transformation of the economy and industry on the Russian side in Russia. May I ask whether this is already the point in the agenda where I am expected to give my presentation? Okay. So you can screen this presentation, please. Thank you indeed. Thank you indeed. Sorry, please, for not being properly prepared at this very point of the agenda to give my presentation. There it is. Now, I like to give you an update on the overall situation of the standardization and its progress for Industry 4.0. Please bear in mind that Industry 4.0 as a concept not only goes into technical details of machinery and manufacturing inside a manufacturing plant, but it goes across companies to interconnect them in a integrated value chain that will go beyond the borders of single companies. Next page, please. The way how the German community for Industry 4.0 has started its own concept building and say architectural engineering and corresponding standardization is being shown in this picture with the three major pillars of the German Industry 4.0 community. First, on top for the steering of the whole project, the platform itself. Second, for the elaboration of concepts for making the needed standards. There is a standardization council, Industry 4.0. And as the third pillar, you see it on the right-hand bottom, the so-called labs network Industry 4.0 that will make sure that technologies and standards are tested closely with each other in order to find out whether they are working according to the expectations. Sorry, please. Next, please. Well, I said it before in our earlier conference, before you start, certainly you would consider to make a plan. And the plan more or less can be said in Germany as far as standardization for Industry 4.0 is concerned, the so-called Standardization Roadmap. The roadmap is meanwhile published in its release 4, and some of the community members even call it is the Industry 4.0 Bible for the German industry and academia and standardization bodies. Such roadmap collects first the use cases, second it determines the concepts, number 3 it identifies the necessary technologies, and number 4 certainly as a major objective of such a document, it identifies the needs of standards, either complementing existing standards or developing new standards. Next page, please. Thank you. So first thing that you gotta do when tackling a pretty complex subject such as Industry 4.0 is to define an architecture. The architecture had already been done in Germany a couple of years ago, which is called the so-called reference architecture model Industry 4.0, with standardization experts forwarding this concept of an architecture to the international standardization bodies such as ISO and IEC. I like to express my acknowledgement at this point that the Russian standardization community, along with ROSstandard, has already managed to implement this particular MACI-X path 63088 into the Russian standardization system of publications where it is now being used to better understand this architecture of a system called Industry 4.0. Next page, please. May I draw your attention a little on what had been earlier referred to as the asset administration shell. It is one of many elements in the concept of Industry 4.0, but I would call it one of the major, if not the most important element. Asset administration shell means that a virtual representation of a real asset will be fully available in a digital format that can be used for any purpose like engineering, simulation, connectivity and operation, and logistics, and many other purposes in an industrial value chain. Well, this asset administration shell describes in a virtual manner, an Industry 4.0 component that might be any asset like a pump, a sensor, a motor, a switchgear, other machinery. And the asset administration shell will, in particular, you can see it on the right-hand side, describe in a manifesto, which we call kind of the header of this description, what the shell in particular contains. And the particularities of this containment are so-called submodels or partial models that will deal with certain aspects of the asset that is being covered by this particular administration shell. Next page, please. So what could such submodels in detail mean in terms of content? What do they describe? Well, for instance, if you think of an electric motor that is given here as an example, there could be a submodel on the left-hand side for the identification of this particular device. Maybe it's got a serial number, it has got a name, it has got some certain information that is usually being represented on a type plate of a machine. So that can be done in a submodel identification. Another submodel, second from left, could be the technical data with all the detailed technical description of the device given like in a data sheet, but not just a data sheet in form of a PDF document, but in a data sheet that fully contains all the digital data in a digital standardized format. Another one is information about operational data, how that device would be operated in a operational environment. And finally, the submodel could also be called documentation that gives additional, say, handbook information for maintenance and repair of the device, or any other useful information on the lifespan of the particular asset. Next page, please. Well, if you look a little closer into such asset administration shell, you can say that the principal description of a submodel will always be done in a standardized format. A standardized format means I make it with a unified modeling language describing what the submodel in particular contains. And on the right-hand side, you would see, well, different containments of different formats of this particular data on the asset you would describe that refer to the relevant submodel. So that can be different standards, meaning that, for instance, it can also become the place where particular for instance, Russian standards can be integrated into such a submodel. The submodel as such, for instance, it just says, this is the description of the maintenance repair book for this particular product. And if there is a standard format that can be used for such purpose, it will be taken. If there is none, you could define a new format, like a Russian one, that in particular describes the way how the maintenance book will be done. And that can be, of course, then digitally integrated as a Russian standard into such a submodel. Next page. The use of a standardized principle, of course, has got lots of advantages. It reduces the effort of mapping of formats of different standards that would be quite complicated as an M2N explosion of relationships and mapping necessities that are outruled and not needed once working according to this submodel scheme of an asset administration shell, because of you would only need a mapping on 1 to n, with one of the n typical proprietary or public standards could be, once again, for instance, a Russian standard that can be integrated into one of those submodels. Next page. Well, to give you a bit of an overview of an idea how asset administration shells in a practical meaning would support complex industrial value chains, this picture might give you an idea of how, for instance, supplier left-hand side, systems integrator in the middle, and operator on the right-hand side will exchange asset administration shell information in between their respective domains for a variety of different purposes. If you look at the left-hand side, of course, the manufacturer, the supplier of, say, for instance, an electric motor, would, of course, make the asset administration shell exclusively for this particular asset, for this motor. That will be forwarded. You see it in this publish box with the little letter inside, like a pismo that goes from the supplier to the systems integrator. And that little letter, that pismo in Russian, contains the asset administration shell that will then be used by the integrator to build a larger system or a system of systems in a particular factory intelligent plant. And again, from there will be publication of new asset administration shells that describe the larger system, including the motor and the controls that have been integrated into a more integrated asset administration shell. If you want, so a bigger one that then will be published and forwarded again in this little letter envelope to the operator that can make use of it in operation of his plant that was provided with supplies from the manufacturer and integrated by the integrator. So in other words, you can see not only the complex supply chain and integration process of making an intelligent factory will be supported by this standardized concept of an asset administration shell, but also in the whole lifespan later on in the operation of that factory, there will always be updated asset administration shells that digitally represent the manufacturing machinery, the processes, and even the products that are made in that factory in a fully virtualized way. This is the key purpose and benefit of using standardized asset administration shells, and that's why they are forming an integral and important part of the concept for Industry 4.0. Thank you, ladies and gentlemen. There is another, sorry, please, last slide that shows a little what the advantages are. The very last, next one, of such asset administration shell. Sorry, please, I had skipped that one. That again, you remember earlier introduction of the unified modeling language and the possibility of mapping to specific technologies such like the OPC unified architecture, the Web of Things made by the World Wide Web Consortium, the e-glass industry semantics repository, or some other Russian specifications that can be integrated into such asset administration shell. So sorry, please, for skipping this one. That is the last slide in my presentation. Thank you indeed. Next one, please. Thank you indeed.
Of the presentation, and I would like to start talking and presenting my report. So I would like to show you the first slide, how the Industry 4.0, how the German product is integrated in the world. So on this slide, you can see the interconnection of different countries. So it is taken from the official website of the Industry 4.0. So you see the leading countries here, for example, China, Italy, France, and so the two-part, three-part committees. And you see an empty space here on the right of the slide. So there should be Russia, of course, but officially it's not officially represented as a government in this scheme. So the committee, or the Eastern Committee of German Economy. So we have been working for a long time together, and I don't say that the German colleagues will say, but I think that we work in an interesting, productive way and get a lot of interesting information. So the next slide, the Industry 4.0. So do we need it or we don't need it? So you see this opinion. So we have some advantages and some disadvantages. So some problematic questions and issues which don't give this platform to develop in our country. So the strategy we have already talked about at the beginning of our project. So I don't like to analyze if we need it or we don't need it. So I would like to say that there is a decision that Industry 4.0 should be implemented in our world and some standards should be created. So our aim is to make this work really efficient, and it shouldn't be divided into independent projects. So there is a large work in our country about the national program. Yes, you see here some national programs of a digital economy in the Russian Federation, some federal projects such as digital technologies, information infrastructure, security, and many, many others. So the next slide shows the scheme in a simpler way. So you see the digitalization and the definition of this word. So it's implementation of digital technologies in different spheres of our lives. So different enterprises, different factories, and of course, unfortunately, all of them are too different. All of them have different standards, and there is not the only one document to regulate it. So you see on the next slide that you see that all the departments form their own architecture or own program support, and you see that digitalization starts working in a very different way. So there is no one project. That is why there will be a lot of difficulties in creation one ecosystem which will be really efficient for our industry. So the government should be interested in this way of development. So different departments of economy and all the interested should have their one interest in our departmental standardization. So here you see what happens in Russia. We have a date 2013. That's the conference in Hanover when the official work on Industry 4.0 has started. So now that's the end of the 2020, but we really don't have the name of this industry in Russia. So of course the name was taken from Germany, Industry 4.0. So we have decided to implement a translation into the Russian language, such as Pромышленность RF 4.0, which is equal to Industry 4.0. So digitalization and Industry 4.0, they are not the same. So digitalization is the third industrial revolution, but Industry 4.0, that's the other thing, is independent revolution. So I gave the names of the French or the Italian name, all these phenomena, and we hope that in the future in Russia will be implemented a term to characterize this kind of industrial revolution. So nowadays now I would like to talk about the aim of the creation of Industry 4.0. So the main goals. There are lots of goals. So first of all, production flexibility, the cost of small-scale products in approaching large-scale ones. So that means that more complete customer satisfaction, of course. Qualitatively high level of competition. Of course, we definitely need this high level of competition. So we don't have to copy everything. We have our own experience, and we should take experience from foreign countries and implement it in our system. That's what is really important. So transparency and data access, increasing the speed and quality of the formation of cooperation, and lack of cross-sectoral barriers. So plug and play. So that's not when we talk about the printer which was connected to the computer. We don't think about it. So plug and play, that's about entry process, the system. So that's what we call Industry 4.0. So that's a really large work. So that's work on organization on the whole process. Of German economy. So, and of course, there are governments. So, and of course, in these fields. And in the center, I would feel that taking into consideration that some kind of applications, the security of web systems, right frames, work, and staff education, and of course, digital business and modules in Industry 4.0. So these standards, that's the basement of Industry 4.0, and of course they are represented in the roadmap, German Standardization Roadmap, Industry 4.0. So the So what we can see on the slide, that's VG, reference architectures and standards, technology and applications scenarios, network system security, legal framework, work training and professional development, digital business modules in Industry 4.0 Mission 2030. So about our future mission in 2030. So what we see here is formulates a holistic approach to the development of digital ecosystems and industrial restructuring for development Industry 4.0. Three central strategic areas of action are of decisive importance here. Mission Statement 2030, autonomy, compatibility, sustainability. The Standards Council's Industry 4.0 took this idea and set itself the goal of promoting the combination of these approaches together with DAIN and DKE. So industry can be implemented in one warehouse. So in order to do it, we should create the standards which should be implemented in all the departments. And so you see that the creation of the United Standards will take some time, and we hope that it will have been finished by 2030. So what about the results? What do we really suggest? So first of all, we should perform an efficient way. Of course, the federal government should be at the head of this working group, because you see, if the government takes the rule of it, so there will be more opportunities to create the United Standards. So we have created 4 different groups, such as thematical structures, so scientific civility on the researchers. So it forms the programs of the researchers. There should be created a center of exchange of experience. So the country is very large. That is why there should be center where all the experience will be shown, and cooperations with other platforms. So there should be cooperation with such platforms as Industry 4.0, Alliance Industrie du Futur, Piano Impresa 4.0. So the thematical structures. So we also have 6 working groups we have been working with. You can see them on this slide. So that's reference, architectures and standards, scenarios of technologies and applications, security of network systems, legal framework, work training and professional development, and digital business models in Industry 4.0. So I would like to pay attention to the fourth structure. So today there will be a report on the artificial intelligence. So imagine that this artificial intelligence will create a good cooperation during some days, and after it finishes with its creation. And unfortunately, there can be implemented some documents from legal framework which will stop this process. So when should we start doing and creating these standards? So I think that it will start in near future, and this process will continue. So we hope that all the people who listen to our projects will share their opinions with us. So that will be really efficient. Maybe something will be added. So here I give my contacts to emails. So please send your opinions about it. We are going to create a special web page. You can see it on this slide too. So thank you very much for your attention. So now, I would like to present you a new speaker. So the new project is Russian Realities for Using Industrial Products Classifiers, ACLIS International Future Classifier. So in some minutes, the presentation will start. So colleagues, I would like to welcome you. I represent the Consilium Codex. So our company is celebrating its series Jubilee. So it works with lots of industrial companies. So you can see these companies and industry coverage production, and such companies as healthcare, energy, construction, machine building, and the names of the companies. So one of the key objects of the standardization is the creation of the one united complex of standards. So there is a real decision that's European international standardization of services and products. On the slide, you can see the important direction of the digitalization of industry in the concept of 4.0, ontological concepted product models and language of interaction between technical systems of classification, codification of goods, materials, services for effective cooperation, and electronic trade compliance with Russian and European norms, standards and rules, development of digital technologies in the field of technical regulation and standardization. So our group is working on the classification of the materials and standards from foreign countries and Russia, and cooperation of the electronic trade. So all the key points you can see on this slide. So about half a year ago, there was a meeting with the German colleagues, and there was a decision that a codex company will promote the ECLA standard for Russian industry enterprises. So you can see the photo of this significant moment in our cooperation and our two-part work. So the European system of item classification, materials, and ECLA services. So classificators in world and Russia, they exist and there are lots of them, then they are not interconnected. So the significant part of the classification is that it's also a standard. So behind the standard, there's expert committee group. So the next slide. So the expert standardized product data system and optimizes all processes in the enterprise, saves resources at every stage of the value chain, effective as primary internal classifier and effective for trading with external counterparties. So there are more than 20 languages are used. So it is developing, it's not only European, in general, it's international. And our companies have also joined it. So our main goals to search ways of interaction between Russian and German organizations in the field of unification of product requirements, search for the possibility of integration between Russian and European product classification systems, and it would be perfect to develop a unified data exchange format. So company has joined the European Association ECLAS and will act as a provider of ECLAS classifier in Russia, conduct familiarization, promotion, training of Russian enterprises, and to conclude licensing agreements for the use of the classifier. We are translating the classifier into Russian and will support the maintenance of the Russian language version. We have developed software for users to work with the classifier, and we will solve the problems of integrating Russian classification systems with ECLAS. So ECLAS standard and Industry 4.0 in techno-expert systems. We publish the information in international editions. So information section on the Tech Expert website, and we also start preparation of technical articles. So all the standards all the standards are made for companies to use them in their standard creation. So that's ontological, concepted model of future product containing a structure of requirements. So is the basis of the digital model. It includes an ontological conceptual models of the product. It describes electronically the product model, what the product includes, what should be its characteristics, what are the technological, operational solutions which should be implemented. The requirements management systems in the total represent the electronic technical design or standard of the product. So all the stages of the product life cycle and contain a certain electronic standard of the product, which must correspond to the real product. So on this slide, you can see the product requirement system, for example, the 5th generation KAMAZ tractor, yes, which was developed in the University of Kazan. And it includes all requirements of international standards. So there are no documentation, just some key points out of this large source of information. So international rules of European Committee were used, and before we got permission to highlight the key standards and to use different kinds of classification. So we suggest the united classification. So we want to turn the use of documentation into digital standards. So the goal of this system, we are working on is very difficult. So of course we should respect all the rights of the program developers. But if we talk about digital economy, we must admit that that's our future. So the systems of demands are used in all large companies. On the slide, you can see the key enterprises using this. So unfortunately, in Russia, there is no implementation of this kind of systems of management. And so we'll have to fulfill and aim this goal. So that's the last goal. So this slide shows the key companies who we are working with. So from different departments, from space, from machinery, from plane buildings. So we see our goal in creation of standards, not only for independent societies, but for the Russian industry in general. Thank you very much for your attention. So thank you very much, colleagues. So I asked Olga Nikolaevna to educate our students using these approaches. So we hope. Thank you very much. Now I would like to give a speech to Pozniev.
Boris Mikhailovich is about to speak. Giving the floor to Boris Mikhailovich.
So,
morning, dear colleagues.
I would like to welcome you, dear colleagues. So, thank you, dear Sergei Anatolievich, for giving me an opportunity to deliver a speech at this conference. So I would like to stress that today we stress at the 10th conference. So thanks to Sergei Anatolievich, this conference was started. So now it's not just the Russian one, but international conference. And we have an opportunity to cooperate with our colleagues from Germany and to discuss some key and important questions about this standardization, the development, and first of all, in the sphere of industry. So maybe I have to define the @SIM. So that's the standardization. So standards are one of the key tool to face the competition in our industry. And the digital transformation is very important now, and formation of the future digital industry in Russia, the creation of prospective digital enterprises and smart productions. So, dear colleagues, let me comment on my presentation. So it is called on the consolidation of the activities of the technical committees of standardization to ensure the creation of the domestic platform RF Industry 4.0. So I would like to pay attention in my speech on the consolidation of the activities of technical committees. So that's the key structures which work on standardization, and how we see this consolidation to support the development and creation of the Russian platform Industry 4.0 we have been talking about. So yes, Sergey Anatolyevich Golovin has already told you about it. So please pay attention to several questions. So the relevance of the creation of the domestic platform industry of the Russian Federation 4.0. So it's quite obvious, but unfortunately not all the representatives of government and industry understand the relevance of this goal, of this object. So international development cooperation industry 4.0. International and national standardization in the field Industry 4.0, coordination of the activities of the national and interstate on the development of standards for the development of the platform industry of the Russian Federation 4.0, and of course proposals for the draft resolution of the conference IT Standard 2020. So, of course, we're going to talk about what have already been done and what will be done in the near future. So, first of all, about the relevance. So, we have been talking about the national programs and the digital ECMO of the Russian Federation. So, there's a strategic document, and all we discuss here, that standards and platform and international experience and educational staff is connected with the largest national program, and speaking about its scale and the scale of different events which are implemented in this program, I would like to mention that 2 years have passed since the beginning of the standard creation, but we see, of course, not so many results achieved, but work continues. So I think that they should be integrated and controlled, I would say. So as you see, there are six key ways, and so information infrastructures, staff, information security, cyber security, digital technologies, digital government, administration. I think, so that's just my opinion. So digital digital technologies are very popular now. They are widely known. You can see them on this slide. So they are divided into sub-technologies, about 217. So we call it end-to-end digital technologies, or neurotechnology and artificial intelligence, quantum technologies, new production technologies, and so on and so on. As an example, I would like to pay attention to the decomposition of new production technologies. As you see, we see lots of famous terms here we are working with, and systems and subsystems we are working in Russia and in foreign countries. We have been working on them for a very long time, but unfortunately we can see the aspects of the integration on the basis of standards in order to get the efficiency for our industries. So in general, we can see here the technology of the smart manufacturing, manipulations in technology of manipulation, and their examples. So the level of efficiency of using them can be shown on the next slide. So the relevance standard for the need. So that's my point of view. And I would say that the need for industry development of domestic of Russian Federation 4.0 is due to strategic, practical platform with the tasks of the Russian Federation in the field of scientific and technological development and transition to the digital economy. The industry of the Russian Federation, which we call 4.0 platform, should become the basis for ensuring competitiveness and creating an ecosystem of the digital industry in the context of the globalization of product markets and the formation of cross-border value chains in accordance with the principles of Industry 4.0 and the requirements of the fundamental standards in the field of digital interaction. So on the slide, you can see the moment of signing of the agreement between RSPP and the Eastern Committee of the German Economy. So the earlier our industry representatives will understand the importance of the standards, the earlier we will integrate into the global systems. So about some words about the committee, we have already talked about it. So I think that it's really important, yes, important event. So it was in 2018, yes, this photo shows. So the structures of the Soviet, of the Council and the Eastern Committee of German Economy. So you can see the head of the projects and working groups, for example, infrastructure of quality and digital transformation. So some significant pictures from the previous meetings. So we have already seen each other millions of times. We have already discussed all of these issues. But now we can talk about the results. So Russia hasn't taken part in the international cooperation, but I think that the cooperation with German colleagues will accelerate the integration of Russia into this process, and we really appreciate the cooperation with German colleagues, the exchange of ideas and experience. So we attentively work with documents of the Industry 4.0, and now I would like to talk about the international national standardization in Industry 4.0. Here I will talk about the regional and standardization. On the slide, you can see lots of committees which work with this issue on different levels. So it's quite difficult to cover all of them and to see there. But in strategic way, that there is a common idea of Industry 4.0. So the model of architecture of Industry 4.0, and we have entered this work on this moment, and I hope that standard committees will actively take part in the international committees work, first of all in MICI. So standards in Industry 4.0. So I'd like to thank Marcus Rigel for sending us this list of standards. So pay attention. More than 550 standards in Industry 4.0. So most of all, we talk about international standards. And if we talk about the Russian part, for us, it's very important to analyze this amount of information and initiate the creation of the Russian standards, which will be implemented in the global system of standards and correlate with the national standards of Germany. So we're just talking about whether the speaker has time or not. So I can say that analytical work is being held. For example, the smart production experts, they are the heads of the national committees, and our experts, which are united in the expert committee of digital committees. So on this slide, you can see the official website of platform Industry 4.0. Of course, we had some difficulties, unfortunately. So because a year about, we started working with the part of international standards, and we tried to implement them at the national level in Russia. And we had some difficulties because we started working with architecture of Industry 4.0, and it was difficult to understand. So, and thanks to our German colleagues, we have found a good solution to this problem. So we have started our work with the analysis of the glossary, digital multilingual glossary. So we call it the key to understanding standards in the field of Industry 4.0. And today we can say that the Russian version of the digital multilingual glossary for Industry 4.0 was developed at the initiative of the Smart Manufacturing Working Group of the Council for Technical Regulation and Standardization for the Digital Economy of the RSPP Committee and the Eastern Committee of the German Economy with active participation. So this glossary is being renovated, and we hope that in the future, the glossary of the Czech language and German language will be created in China. Yes, we know that in China and South Korea, the experts are working on this problem. So that will be, I think, a key option to find the global standards for Industry 4.0. So I think that there will be one standard of the European level, and every country which pays attention to this industry development will create its own standards, which will become part of the global one. So they can be easily integrated and cooperate inside this ecosystem. So I would like to thank the representatives of Codex for the glossary edition. So I don't think that we should pay too much attention to the model of architecture of Industry 4.0. So the reference architecture model is universal in nature and is basis for the creation of smart factory, digital enterprises, holdings, and corporations, ensuring their integration and interoperability in accordance with the concept and standards of Industry 4.0. And applying a layered model was describing and tracking assets throughout their life cycle. So about coordination of the activities of national and interstate on the development of standards of the development of the platform industry of the Russian Federation 4.0. So on November 24th, at a meeting of the Interdisciplinary Council for Standardization in the field of information technology, it was decided to create a coordination council of the chairman of the national and interstate technical committees and standardization in the field of digital development within the framework of the RSPP Committee of Technical Regulations. So the key events of 2020. So first of all, information technologies in machinery production, in a PROM platform, and two other international conferences, including the present one. So now I'm talking about some proposals, and you could see them on the slide. Thank you very much for your attention.
So I'd like to give word to Sergey Anatolyevich Garbuk, and there is a suggestion to have a 15-minute break, so that we'll have all other reports according to the schedule. So let's have a short break, and maybe we'll meet again at 13:25. Okay, a short break for 15 minutes. Thank you.
So I give speech to Sergey Gdinilch, so about the artificial intelligence in industry. So thank you very much. Hello, dear colleagues. So my report is devoted to the standards of artificial industry in industry. So in spite of the fact that everybody is talking about artificial intelligence, there is no clear definition about it. So the March of the second year of the next year, there should be created a new standard devoted to the artificial intelligence, where artificial intelligence will be defined. So according to the last plenary meeting, the ISO committee has decided to put off the creation of the artificial intelligence standard, because there is no just one opinion on this subject. So the second situation occurs in our country. So my report will be divided into two parts. The first one is in the first part, I will try to define artificial intelligence, give the definitions and its characteristics. And the second part is the description of the standards which were created on the national level. So the first part of my report. So there are two main approaches. So artificial intelligence is very close to human natural intellectual abilities. So when I talk about it, we can say that means the ability to recognize and perceive objects, ability to use intuition, ability to take into account the surrounding context, and many others. So on this slide, we talk about the main functional classes of intellectual tasks. We talk about pattern recognition, navigation. In general, there are 6 main blocks. They are painted into orange. So that's pattern recognition, navigation, traffic control, traffic moving, aids perception, accumulation of knowledge, impact on the environment, generalization, fuzzy search, physical impact management, census, memory, manipulations. So this slide shows the analysis of variants of implementation artificial intelligence into the industry using the system of IFORA analysis of data. So there was developed a project into the Higher School of Economics, and the results were obtained after the research of articles and experiences in the sphere. So on the slide, you can see artificial intelligence use cases report. So in general, a total of 132 typical use cases for artificial intelligence in the following areas: right, logistics, maintenance, and repair, industrial production, transport, retail, safety, and many others. So on the slide, you can see artificial intelligence and the concept of development of Industry 4.0. So finally, we have studied the experience of the leading countries. So there are some statistics about the budget of such countries as Russia, United States of America, China, Germany, and Japan, and how they solve the problems they meet. So going back to the main functional classes of intellectual tasks in industry. So There you can see object detection, localization and pattern recognition, autonomous movement of industry, building models of surrounding objects, making decisions using predictive modeling, implementation of physical effects on objects and processes. So on this slide, you can see the scheme showing the main functional classes of intellectual tasks and industry. So first of all, pattern recognition, which includes non-destructive quality control, industrial robotics, technical vision, augmented reality support. So the next part is converting design documents to digital form building models. It includes virtual testing of complex projects, simulators with simulation of complex production and technological process. So here we talk about general models. So first of all, our aim is to test these virtual complex products. So that we talk here about environment and the difficulty is that we can't use analytic models here. So we need to use models which are based on data. So the last aspect is more about education. So the next one is certain of decision. First of all, predictive maintenance of industrial equipment. So we should forecast the decisions, and that's what human creatures can do. So only human can understand where there will be more advantages or disadvantages of every step. So on this model, the equipment works, so we can just in time forecast of repairment of equipment. So when it should be repaired, when it should be replaced. So when we talk about when we talk about information safety, not just filtering traffic, but broadcasting the consequences of every comment of the program. So only after analyzing all the consequences, we can make a decision about whether it has more advantages or disadvantages. Should it be used or should we stop using it? So engineering consulting. So artificial intelligence can build a cooperation of orders. So having industrial equipment and the objects so taking into consideration with the data, we can build an make optimal decision. So the last goal is optimal warehouse management. So here we talk about minimization of warehouses in order to economize, in order to reduce our spends. So physical impact management. So first of all, here we talk about industrial robots. So of course, all the robots should be controlled using the data after carrying on the experiences. So for example, if we talk about the turbines, so these kind of analytical tasks have no solution. That is why artificial intelligence should be used. So here we talk about going back to physical impact management. We talk about dynamic manipulation and the control of responsible manual operations. So artificial intelligence can help human creatures to find mistakes. That's a real solution to problems exist, because sometimes people just don't pay attention to some problems, but artificial intelligence using the data and the previous experience can work out warnings in proper time. So here we talk about, of course, navigation and supply. And the last block of objects. So searching of decisions, predictive maintenance of industrial equipment, predictive control of industrial equipment, engineering consulting, optimal warehouse management, motion control, industrial robotics, interior and navigation, transport and logistics tasks. So, and the last one is the educational block, how to educate staff, working with artificial intelligence and robotics. So that's the list of the our scientific approach to this issue. So now I am going to the next part of my project. So that's big data, the standards of artificial intelligence. So here we talk about big data, unification and presentation formats, learning from use cases, standardization, the requirements for training data sets, lack of interpretability, opacity for artificial intelligence algorithms, standardization of requirements for test data sets. The fourth one, automation of human intellectual activity, standardization of methods for measuring applied intellectual capabilities. And the fifth point we suggest here, confidentiality of training data sets, standardization of guarantee data depersonalized procedures. So the quality of every system should be tested. And that is why we need to produce standards in order not to make the mistakes. So going back to the fourth point, I would like to say that the operator, represented by a human, should be held by artificial intelligence if we talk about industry and production. So the main standards are created in order to constrain associated with regulatory defenses in artificial intelligence in industry. So here we talked about unwarranted quality of work, opaque decision-making logic, susceptibility to attacks, limitations on the use of artificial intelligence system in solving mission-critical tasks, and lack of standard procedures for comparing the functionality of artificial intelligence systems with each other and with the capabilities of qualified human operator. So in general, there are three main problems. That's the lack of believing in the system of artificial intelligence, methodological difficulties, and the problems of interoperability. So all the standards are divided into two large groups. First of all, types of artificial standards, general purpose standards. That means terms and definitions, formats for description and data markup, ways to depersonalize data, general principles of quality assurance for artificial intelligence systems, and classifications of use cases for artificial intelligence systems. And the second type is metrological standard, that methods for confirming the safety of artificial intelligence systems in real operating conditions, and ways to reliably assess the characteristics of artificial intelligence systems that determine the effectiveness of their intended use. So, speaking about Russians, we can say that there are different programs and initiations which are held now in Russian Federation. So I won't highlight all of them because you can download this presentation after the conference. So, but I would like to highlight the first point, a promising standardization program in the priority direction, artificial intelligence for 2021-2024. And we hope that it will be taken and we will continue working on it. So as I have mentioned, there are two main groups of standards. So there are more than 200 of standards of artificial intelligence divided into common standards and metrological standards. So the next slide shows the standards of artificial intelligence industry. In a prospective program for 2021 and 2024. So here we talk about artificial intelligence and its use in the migration and of looking for products. So thank you very much for your attention. So that was a very interesting project. So artificial intelligence isn't widely studied. That is why there are no proper standards. But now we have the different situations. First of all, we make standards and then we understand what the standard is made for.
Thank you very much, Mr. Oliver. It was very, very interesting report. We have a lot of questions. We'll contact you soon. It's a lot that we So the general director of the E-Class, Kroki Torsten, will have a word. This is the final report for today, and it's the final report for E-Class Complex. Please. Thanks a lot. We're really close tied with the Eastern Committee. We'll definitely ask some questions to you. We hope that it's not the last time we see each other. We hope to develop this direction. We hope that we'll move to this new direction, and we hope that we'll have a black patch instead of the gray one. So Andrei Nikolaevich would like to have a word. Give a word to Andrei Nikolaevich. Lotsmanov. So I'd like to thank Mr. Golovin for this wonderful conference and the opportunity to take part in it on the premises of the university that actually is preparing the experts and specialists. It's Industry 4.0. I'd like to thank the participants for wonderful reports, and I hope that next year the quantity will lead to quality, and the theoretical discussions will lead to implementation of these programs in Russia on the government, on the state level. And I'd like to show a slide. That's what we have planned in terms of our council work. So we will be happy to listen to your suggestions. In March, April, we'd like to have a seminar in the machine readable standards. So we hope that it will be interesting for a broader audience. In July, we'll have a traditional INAPROM 2021. We are looking forward for holding this forum with a huge number of experts from various fields. In October, we'll have a seminar in the European Commission about the technical regulations. And also the Kazakhstan experts and the Belarus experts would like to participate in these kind of seminars. In October, we'll also have a traditional conference in the framework of the Russian Business Week. And in a year, we hope to see you in Mira at the conference, at the IT Standard Conference. So we're looking forward for this opportunity and see each other face to face. We're looking forward for this. And let me wish you in the following year a lot of health, a lot of happy days ahead. So thank you very much. I'd like to second these words, and it's really hard to hold conferences in December, and we'd like this coronavirus pandemic to be over as quickly as possible, so we meet as we did 9 times before. No matter what, the best way to hold conferences is face-to-face conferences, the actual conferences. Thank you very much for wonderful reports. So when you listen to this kind of ideas and reports, you have a lot of ideas of your own, of course. So I hope that our German friends were interested in what we are doing, and I wish you wonderful holidays, wonderful weekend, and Happy New Year. Thank you. Thank you. See you next time. Goodbye.
Happy holidays, greetings, do svidaniya to Moskva. Stay healthy, enjoy your Christmas time, and get a nice start into 2021. We will hopefully see each other soon in person at Miria or Stankin University. Thank you, goodbye.